What if the answer to one of humanity's greatest questions is hidden beneath a frozen world billions of miles away? For centuries, people have looked up at the night sky and wondered, are we alone in the universe? Today, that question feels more exciting than ever because of a remarkable discovery involving Enceladus, one of Saturn's icy moons. At first glance, Enceladus does not seem like a place where life could exist. It is small, extremely cold, and covered with a thick layer of ice. But beneath that frozen shell lies something extraordinary, an enormous ocean of liquid water. Even more astonishing, giant geysers shoot water vapor, ice particles, and organic compounds high into space from cracks in the moon's surface. Recent studies of these plumes have revealed ingredients that are considered essential for life as we know it. Scientists have detected organic molecules, carbon-based compounds, and evidence suggesting hydrothermal activity deep within the ocean. On Earth, hydrothermal vents on the ocean floor support entire ecosystems filled with unique forms of life, even in complete darkness. The presence of liquid water, energy sources, and organic materials makes Enceladus one of the most promising places in our solar system to search for extraterrestrial life. While no direct evidence of living organisms has been found, the conditions appear surprisingly favorable. Some researchers believe that if simple microbial life exists anywhere beyond Earth, Enceladus could be among the best places to find it. What makes this discovery even more incredible is that future missions may not need to drill through miles of ice. The moon itself is already spraying samples from its hidden ocean into space. Spacecraft can potentially fly through these plumes and analyze their contents, giving us a unique opportunity to search for signs of life directly. Enceladus has a hidden ocean. Beneath its icy surface lies a vast ocean of liquid water, one of the most important ingredients for life. When most people imagine places where life might exist beyond Earth, they often think of distant planets orbiting faraway stars. However, one of the most exciting possibilities may be much closer to home. Enceladus, a small icy moon orbiting Saturn, has captured the attention of the scientific community because it appears to contain a vast ocean hidden beneath its frozen surface. Although the moon is covered by a thick shell of ice and experiences extremely cold temperatures, evidence suggests that liquid water exists deep below. This discovery is significant because water is considered one of the most essential ingredients for life. Wherever liquid water is found on Earth, life is usually present in some form, from microscopic organisms to complex ecosystems. The hidden ocean of Enceladus is believed to contain more water than many lakes and seas on Earth. What makes this even more remarkable is that the ocean remains liquid despite the moon's freezing environment. Internal heating generated by gravitational forces appears to provide enough energy to prevent the water from completely freezing. Scientists believe this underground ocean could have existed for millions, or even billions, of years, giving any potential life forms plenty of time to develop. The discovery of such a stable and potentially habitable environment has transformed Enceladus from a little-known moon into one of the most promising locations in the search for life beyond Earth. Powerful geysers reveal ocean secrets. Massive plumes of water vapor and ice erupt from the moon, carrying material from the underground ocean into space. One of the most fascinating features of Enceladus is the presence of powerful geysers erupting from its southern polar region. These geysers are not ordinary surface activity. They are massive jets of water vapor, ice particles, and other materials shooting hundreds of kilometers into space. They emerge through long cracks in the icy crust, often referred to as tiger stripes, which act like natural vents connecting the hidden ocean beneath to the surface. This means that instead of needing to drill through kilometers of ice, scientists can actually study material from the underground ocean simply by observing or passing through these plumes. What makes these geysers especially important is what they carry with them. Along with water vapor, they transport organic molecules and other chemical compounds that may be crucial for life. Space missions that have flown near Enceladus have sampled these particles and provided strong evidence that the moon's interior is chemically active. This activity suggests that there may be energy sources beneath the ice, possibly from hydrothermal vents on the ocean floor, similar to those found deep in Earth's oceans. The continuous eruption of these plumes also indicates that the internal ocean is not stagnant, but dynamic, and possibly capable of supporting some form of biological activity. Essential building blocks of life were found. Organic compounds and other life-supporting chemicals have been detected in the plumes, making Enceladus a strong candidate for hosting life. Among the most important discoveries related to Enceladus is the detection of organic compounds within the material ejected from its icy surface. Organic compounds are carbon-based molecules that form the fundamental building blocks of life, as we know it. Their presence does not confirm life, but it strongly suggests that the chemical ingredients necessary for life are available in this distant ocean world. Scientists have analyzed particles from the moon's geysers and identified a variety of complex molecules that indicate active chemistry occurring beneath the surface. What makes this finding especially intriguing is that these compounds appear in an environment that also contains liquid water and a potential energy source. On Earth, life thrives in environments where water, energy, and organic chemistry interact, particularly around deep-sea hydrothermal vents. The similarities between these Earth environments and conditions suspected on Enceladus raise the possibility that similar chemical processes could be taking place there. Some of the detected molecules include carbon, hydrogen, oxygen, and nitrogen combinations, which are essential elements for amino acids and other biological structures. However, scientists remain cautious. The presence of organic compounds does not automatically mean life exists. These molecules could also form through non-biological processes. Even so, their discovery significantly strengthens the idea that Enceladus has a chemically rich environment capable of supporting prebiotic or even biological activity over long periods of time. Conditions may be similar to deep-sea life on Earth. Evidence of hydrothermal activity suggests environments similar to Earth's ocean vents, where life thrives without sunlight. One of the most compelling reasons Enceladus is considered potentially habitable is the strong possibility of hydrothermal activity occurring beneath its icy surface. On Earth, hydrothermal vents are found deep in the oceans, where seawater interacts with heated rock beneath the seafloor. These vents release heat, minerals, and chemical energy into the surrounding water, creating unique ecosystems that thrive in complete darkness. Remarkably, these Earth environments do not rely on sunlight for energy, which expands the definition of where life can survive. Scientists believe a similar process could be happening inside Enceladus. The gravitational pull from Saturn creates tidal forces that flex and heat the moon's interior. This internal heating may cause water in its hidden ocean to interact with a rocky core, potentially producing hydrothermal vents on the ocean floor. If such vents exist, they could supply both heat and chemical nutrients necessary to sustain microbial life. This idea is especially exciting because it suggests that life could exist in environments very different from Earth's surface condition. The discovery of possible hydrothermal activity also helps explain the chemical richness found in Enceladus's plumes. Minerals and energy released from the seafloor could rise through the ocean and be carried into space by the moon's geysers. This connection between geology, chemistry, and potential biology makes Enceladus one of the most Earth-like ocean worlds discovered so far. Despite its distant and frozen appearance, the search for alien life is more promising than ever. Future missions can analyze the moon's plumes directly, potentially discovering signs of extraterrestrial life without drilling through the ice. The possibility that Enceladus could support life has transformed it into one of the most important targets for future space exploration. Unlike many distant exoplanets that are extremely difficult to study in detail, Enceladus offers a rare advantage. It naturally ejects material from its hidden ocean into space. These plumes provide scientists with a direct opportunity to study what lies beneath the icy surface, without needing to land or drill through kilometers of frozen crust. This makes exploration both more practical and more promising. Future missions are being designed with the goal of flying through these geysers to collect samples and analyze them for signs of biological activity. Instruments on such spacecraft could search for complex organic molecules, chemical imbalances, or patterns that might indicate living processes. Even the discovery of simple microbial life would be a groundbreaking moment in human history. proving that life is not unique to Earth. The implications of such a discovery would extend far beyond astronomy. It would reshape our understanding of biology, evolution, and the conditions required for life to exist. It would also raise profound philosophical questions about humanity's place in the universe. Even if no life is found, studying Enceladus will still provide valuable insight into how ocean worlds evolve and how common habitable environments may be across the solar system.